Thanks for joining me this afternoon for this talk. I'm Haroldo Olivieri. I'm a principal software engineer at Skyscanner with flights, as you should know. And I'll be talking about honest mistakes caused by shallow interpretation of solid. It's when designing new solutions, it's quite common that we're normally taking isolated principles into account, normally from solid, and we even ignore company's context or product requirements. They might even be more important to the scope of the problem. Some other times, we can also notice a pattern of confirmation bias, where it's really hard to move forward the conversation because the involved people have normally their own diametral opinions of the same topic, because normally they based on their own assumptions. So this talk is about recognizing these destructive patterns in your team and for you to know how to build the right thing as long as you're building right. So this talk will be split in 5 parts. First, I'll talk about trend-based decisions and how they can be harmful for our environment. Then I'll try to create a common ground or talking about design principles, design patterns, what they are, some examples and common mistakes. Then we'll talk about following patterns by the book and why this might be a good thing or not. Then the part that I think should be the most important one is telling what we did at Skyscanner to help us to base our decisions. And last but not least, I'll follow us through the key learnings. So starting from trend-based decisions. I can bring some examples from interviews I've conducted where I talk to candidates and normally ask them, tell me about a project you're working on, architecture you've been working on, or why you choose the architecture, or problems, trade-offs that we're working on. And it's quite common I have similar answers where it goes from when I joined the company was already like that, or something like I'm obviously using MVVM because it's Google recommendation. And when you ask something, you can go further. You don't go, it's a very shallow conversation. Don't get me wrong, I'm not saying you should join a company, just kick the door and start everything from scratch, or write a completely custom framework that we're working on libraries and creating a really long learning curve for onboarding engineers. That's not what I'm saying, because following industry standards is normally a good indication of success for architectures, design patterns, and principles. But if you go in with something, if you join a company, and even if you don't have the power to change what is going on there, you should know what are the trade-offs or architecture you're working with. So what I'm saying is to prefer one option over another, you must know what are the trade-offs. And one thing I would like to ask the initial question that I'll come back to this later. Do you believe it's enough saying MVVM is the architecture your project follows? I'm not answering this right now. I'll talk about design principles and patterns, and you can come back to this later, and you can tell me. So design principles. Software design principles are a set of guidelines and best practice that help us developers to code good quality code. Simple like that. We have, there's a handful of this, but we all know there's way more than this. So here you can have keep it simple, stupid, KISS, that is simplicity should be the goal, and necessary complexity should be avoided. Dry, that is quite self-explanatory. Don't repeat yourself. So avoiding duplication of code and use abstractions and reuse your code as much as possible. Composition over inheritance, where it states that relying on composition is often more flexible and more maintainable than relying on heavy inheritances. And we have solid, that is actually a collection of principles. I forgot saying at the beginning that the name of this talk is quite of a bait, because I mentioned solid because it's a buzzword and everyone likes listening to this word. But actually, you can fit any design principle or pattern to the title of this talk, and it will still fit. And one curiosity here, clean code is not a principle, but a collection of principles and conventions and code quality, and sometimes even algorithms that also help us building good code. That's just a curiosity. Okay, we have a lot of principles, way more than the ones I have here. Just for a solid, we have 5. So one thing that is really important is to notice how the principles influence one another. And I can give you an example here. So let's talk about composition in solid. For the first one, single responsibility principle, it states that one class should have only one reason to change. To achieve that, you normally create smaller classes, and to create the full behavior of your class, you go through composition. So they are directly, like, really related. Open-close principle encourages that one class should be open for extension but closed for modification, and we normally achieve that by composing these from other behaviors as well. Least scope substitution, that's an interesting one, because although it talks about polymorphism and inheritance, I believe that you'll only be able to apply it correctly if you know how to apply composition correctly. Because when you talk about composition of inheritance, we need to understand the relationship between your classes. So you need to understand the relationship is class A is a type of class B, or class A has a type of class B. And you'll only be able to apply composition and least scope substitution correctly if you get this relationship. Interface segregation, it says instead of having monolithic interfaces, you create smaller ones, and you have really defined APIs. So when you have smaller behaviors in smaller interfaces, you need to compose them together, so also related. And last but not least, dependency inversion. To be able to achieve dependency inversion, you need to rely on interfaces and abstractions, and they normally rely on composition to be able to do that. So you can do this composition solid, but you can choose other principles and try to look how they're related. But you should not get into the trap thinking that if you take one principle, you might get all the others together because they're related. That's not true. We should never take a single principle as the main guidance of our solution. And I'll give you some examples. I'm pretty sure most of us have faced the base class before. I'm not saying it's a bad thing. Actually, I'm saying it is a bad thing. But the thing is, when you work in a base class, you might follow some principles, but you might ignore some others. So when you do this, you're definitely following dry because you're not repeating yourself. You are creating a single place that centralizing this code, reusability is going to be achieved. Great. Some might argue that keep it simple is also followed, but I never seen a base class that didn't grow really become a god class later on. So it's really hard when you go for a base class model that you keep following, you keep it simple. So personally, I would say you would harm this over time. Composition of inheritance over inheritance, we're definitely not following because we are inheriting from a base class rather than composing. And now on solid, on the single responsibility principle, I could argue that this base view model, this abstraction of a base class is doing more than one reason to change. So I could say that it doesn't. On open-close principle, I'll go with the similar argument I used for KISS. Although right now we have a generic, and the way the view model is, it might not have to change too much to expand. It's most likely that in the future we'll find examples of view models that need something very specific that the others don't, and you need to add an if or a switch case into your base view class. And that probably happens. And interface segregation principle, if you treat the base view model as an interface, you see the view model scope. I can think of examples of view models that might not need a view model scope. So it would still need to conform to this interface. We'll probably put a nullable there, but then you're creating a wonky interface and contract for the future. So, okay, this is another example. So take these two engines here. One's a diesel engine that only starts, and an electric engine that starts and regens. Now is the car that not implements, but consumes these engines. This car has two engines, although a car only have one engine, but it has an electric one and a diesel one. And on the start code, it checks its type. And depending on type, it checks how to start. And the regen, only the electric one is used. This code follows composition of inheritance, and it does follow single responsibility principle, because we have separate classes doing separate work. But if you see this switch, not this if on the start method, breaks directly the open close, because if you need to add a hybrid class here, you need to change the code of this class. Liskov substitution and interface are not obtained here because you don't even use abstractions. Dependency inversion does not follow because electric and diesel engines are low-level modules, and our high-level module is depending on those. So we're also not respecting, and not either dependency injection. So let's tweak this code a little bit. So now we added this interface, iEngine, and does both start and regen, and both diesel and electric engine are implementing this interface. Okay, now we are respecting open close because our car can change for any other type in the future without changing itself. And dependency inversion is also followed because our class is injecting an engine that is an abstraction of an engine, and you don't need to know anything about this low-level module. But if you look at this detail here, when we implement regen from the diesel engine, we actually throw in an exception because it should not be implemented. We don't do regens on diesel cars. And because of this, we can see that Liskov is not respected because our children do not behave as the expected parent. And also the interface segregation principle, because everyone has to implement regen while regen might not be a thing. So if you tweak one more time, there's one more thing. Here we have the set engine. The reason why I'm saying dependency injection is not respected is just to give an example how dependency inversion and dependency injection are different things. Although you can say this is a method injection, it's not exactly what you're looking forward when you're doing dependency injection, because you will end up on a position where your engine might not be started, might not be initialized. So I could argue that dependency injection is not being followed as it should. So now we create a new interface that is iRegen engine here, and it only regens. And now we have a diesel engine and electric engine implementing the correct methods. Now we're following Liskov, interface segregation, and all the others. And now we have two different cars. One that is a car that can only use an engine, and the other car that uses a regen engine. So you can have a petrol and a diesel car following the first one, and a hybrid and electric car following the second. And with a small tweak, we can just get this method injection and turn it into a constructor injection and follow everything. I'm not saying this is the perfect code or how we would code. I'm just trying to create a most close to a real-life code to explain how we need to think about every single principle separately rather than solid as a magic thing that just single responsibility principle solves. So now we should never take a single principle as the main guidance. That's what I meant. Next step, let's talk about design patterns. So design patterns are typical solutions for problems that are recurrent. So pretty much you can think about a blueprint or a template that you can fit your problem into and see how, with small tweaks, how to work. So you can think of like someone has faced this problem before and they created a structure to how to solve it. Design patterns are divided in 4 types: creational, structural, behavioral, and architectural. Creational is focused on the creation mechanisms. So provide flexibility in creating objects while keeping away from implementation. Examples here are factory that provides a way to create an object, builder that lets you construct complex objects step by step, and singleton that is a class that only has one available instance at a time. Structural focus on the composition of classes into larger structures. So facade provides a simple interface for a complex system. Adapter makes 2 interfaces that they are incompatible to collaborate together. And decorator adds dynamic behavior to a class over wrapping. We have behavior that talks about interaction and communication between objects. So we have kinds of strategy that can change the behavior of a class in runtime. We talk about observer that probably everyone here knows. We can talk about RX, the manifesto of I forgot the word, and also can do pub sub and flow. So in command is encapsulates a request into standard. Now the last one, but the one we're probably really talking on this talk is architectural. Here on this architectural, for the sake of this this talk, I'll be splitting in two cases. One is domain focus and the other is presentation focus. We definitely can have more examples, but I'm just keeping it short here. Presentation focus, as the name says, I'm talking about what is presented to the user. So when you talk MVC, MVVM, MVI, and all the letter of soups you can have with view on it, normally talks on presentation. And domain focus normally talk on the core components related to the business requirements of your application. For example, clean architecture and domain-driven design. So talking about these two, when you look at the diagram that explain they both, they're very similar. And the thing that is the most similar one between them is the center. On this center here, okay, I just don't know how much time has passed. Okay, I'm good. So on this center here, you can see that they both refer to core components of the software architecture. They encapsulate business logic and everything that isolates from any data related to the application's domain. So really, it's definitely not optional. Working with the domains and the entities are what drives any of these two architectures, and all the other layers can communicate to the domain, and they should communicate to the domain. As you can see in both architectures, the user interface is the last one. And they don't really care about what is this user interface. It can be a terminal. It can be a piece of paper. Anything that will plot something on the screen. What really matters is how you put things together to make sure you're relying on, you're following the business requirements of your application. One interesting point is that we have some concepts and patterns used in both of these architectures that we use in our app. So I can talk about repository pattern. Repository pattern is a design that is normally used to separate, abstract the data access logic to the rest of the application. As Android engineers, you might have worked with this before because it's even recommended by Google to use repository patterns. But the way it's used is different. Repository pattern was not created by DDD, but it will gain a lot of preeminence after that. And the same for separation of concerns. Separation of concerns is actually a principle, and most of architectures follow that, but this concept as being used was really like raised by Uncle Bob from clean code and clean architecture. So you can see there's two things that use it on modern architecture for app for mobile development. So I'll ask you again, do you believe it's enough to say that MVVM is architecture that you follow? I'm not answering. So let's talk about following patterns by the book. So talking about Google, let's see Google's recommendation. One interesting thing here, it's really small, so I'll read here. Data layer of an app contains the business logic. The business logic is what gives value to your app. It's made by rules that determine how your app creates, stores, and changes data. So they're talking about both data and domain at a data layer of what Google recommends. And what is interesting here is that the domain layer, that is the one that holds your business logic and product and business requirements, is actually optional. It's interesting how it brings repositories and data sources from other architectures and other patterns, but it still nitpick into a different architecture that might not follow what the domain-focused architectures do, but might still do it right. And an interesting is the domain that is actually optional. If you see what they say it should be, it's meant to be for more complex cases where you need to orchestrate different repositories or a more complex business logic. And you build, for example, a use case, and you leverage this to orchestrate other repositories. But it's optional. So in practice, it would be something like this. We have a view model that communicates directly to an implementation or interface of a repository that is on the data layer. But in this case, I can only imagine that this app consumes a data source that has a really UI-ready content, meaning when you consume it, there will be a GraphQL or a BFF that returns pretty much a view model out of your need, and you can actually treat this as a domain. This is one real case, and I'm sure you might have faced this in your applications. Let's think about a hypothetical case. Now, to build your model, you don't have this ready from a single API. You actually need to consume two APIs. Imagine you're creating a user, and you need to get his birthday from the first one and the rest of data on the second API. Terrible modeling API, but sometimes it happens. In that case, how would Google say to you to base it on their approach? So most likely you'd have to create a use case that would consume 2 repositories and consume these 2 APIs. But now you have a problem that the domain layer is optional, right? But the model is on the data. Model is meant to be immutable. You should not create and just change your model later on. Even Google recommends that. So you use unique data flow and single source of truth. If you want a model to be immutable, how can this be at the repository layer if it needs to be orchestrated at the use case layer? So it would create a wonky contract where your model is in between. So although you might not really be able to explain why that happens, you feel it weird, and you should go with your instincts. So thinking about DDD, how would be like a really shallow solution for this problem? So in DDD, rather than UI, domain, and data, would have presentation, application, domain, and infra. Infra is the part that talks to gateways, databases, and anything that it's not directly related to your business. It can be isolated, it can be abstracted. One interesting point here is that it forces you to have an interface of a repository, and the interface is part of the domain while the implementation is part of infra. It happens because the interface only knows the model, while the implementation knows DTOs and response models and models, so they can do this mapping. And the way they consume it, they use an application service to consume one or many repositories. If you want to make it simpler, we can just use the naming we use from Google. So there will be UI, domain, data, and use case and the interface would be both in the same layer, and they would consume the implementation on data. But let's be honest, for most of the cases, this is more than enough. If you're working on read-only apps or simple apps that bring data from the domain, you might not need all these layers. So not recognizing that unnecessary complexity is as harmful as creating naive solutions for complex problems. So what I mean here is that no matter what you're going with, you should know the limitations and trade-offs of your architecture before you face this in real life. Because you don't want to know that your architecture is not enough when you really need this for real. So go for the trade-offs beforehand. But how to do that? How to base my decisions? So on this point, the first thing, one interesting one, is talk the same terms. What I'm saying is, we just saw domain-driven design, an example, and Google's, and the names are very similar, but really not. So domain layer for DDD is data layer on Google's approach. Application layer is domain layer. Infrastructure layer is data layer. And presentation layer is UI layer. I've been in many conversations where we're talking about architecture, design patterns, and layers, and we end up thinking we're talking the same thing, and later on realize we're talking absolutely different things for a really tiny change. And that's mainly because we have very similar names and nomenclatures for different conceptual things. So what I really recommend that we did as Skyscanner is pretty much a glossary. So when we're talking about layers and what is part of each layer, from a very high level, create what you really mean. So what is, when I say presentation logic, how many times I say, what do you mean by presentation logic? So stop having these conversations all the time. Just create it, that's what we mean, and really state this. So we'll be on a Confluence page, on a Wiki page, on a README, on a GitHub. No matter what, you need your engineers agreeing and reviewing it. So it will be like the language you talk at your company. So an example, if you have UI layer, you say, okay, UI layer is part of UI, and UI has UI state, UI elements, UI user events. That's the naming we're using. And for presentation logic, we have dispatcher, publisher, whatever. I'm not saying view model or anything. I'm saying about the components. If you talk about a view model might have both dispatcher and publisher on it. It doesn't really matter how we implement this. It's more about how I will name this. So the same about domain layer, data layer, or any other layer, because you might not even use UI layer, data layer, and domain layer. It's up to your team. Take your company's context into account. That's very easily ignored. So consult relevant stakeholders, and I'm not talking about your staff engineers. I'm talking about product people, design people, and marketing people. I can give you an example. We did a rewrite of deep links that would affect every single feature in the app. But actually, what it would affect the most were the app marketing campaigns. So we had to talk to the marketing team and understand what were their needs, compared to the first version of deep links. And we talked to them, we realized we had a lot of assumptions of what they need that were completely wrong. And we were able to remove a lot of tooling and complexity from our code base because actually they need less than we expect. So don't try to assume things. Talk to the right stakeholders. Understand your company's long term. I'm saying this because companies, especially this is especially true for startups. You might talk about resources, headcount, what is the plan for 5 to 10 years, and how you can put your technical stack in favor of that. So I can give an example. Skyscanner, as you should know, is a flights, hotels, and cars company. So we work with CPC sending you to the final provider. So when you see what is coming from the execs and talking to product, what they always saying is consistency in a matter of your user experience and UI and user experience, and also from a product perspective. So how can we bring consistency to a level of engineering to support them in the long term? And the last one is know what real value means, because value might be revenue, value might be what they deliver to your final user, or value might be happiness of your engineers. So the only folks that know that it's you and your team. There is a talk that I gave 2 years ago talking about that here at DroidCon. So if you look for my name on the DroidCon, you might find. So and I'm going further on this case. In a world of limited time and resources, that would not be necessary. But unless you work on a company that just throw money at the problem, you still might need to want to look to these problems. And even if you work on this kind of the companies, you still might want to look at your real context of your company, because you might create something different. You might show things that could be done differently. Okay, and now trade-off analysis. How to avoid confirmation bias. One thing, I really believe it's okay to be strong opinionated as long as you're able to give steps back when you see you're wrong. So you need to be open enough to say, okay, I was wrong, let's do this right, go forward. So you're really nurturing this confident environment in your team. But to achieve that, I really also believe that every company should have a technical strategy that they can follow, so they can use guardrails on what they talk and try to avoid as much as possible personal opinions. A software engineer's strategy typically involves a set of policies that guide the work and decision-making process. So thinking about that, at Skyscanner, we create a set of architectural policies in order to guide our conversations and try to avoid confirmation bias as much as possible. What are the rules for architecture policies? They're meant to be platform agnostic. So in this case, we're talking about mobile. So be Android and iOS, it cannot be specific. We need to think in a very broad manner. They should be based on a common ground, and that comes a glossary, because it's impossible to talk this if you're not using the same terms. They need to be detached from the chosen architecture, because as a policy part of a strategy needs to be longer term than the actual architecture. Your architecture might change over time, and your policies don't have to. Your policies need to be generic enough to talk about any architecture you're coming, but it's specific enough to be able to scope what the conversations are having. It's not easy to write, but it's very, very helpful. And this one. And the last one is agreed by engineers. You don't want to just top-down decisions on your engineers on what they should do in terms of architecture. You want them reviewing this, bringing in ideas and bringing the possible risks and concerns, because they're really close to the problem. So the architecture policies are meant to create common assumptions and keep the scope of the conversations constrained. And why is this important? Because when you're talking about code reviews, system design, and design reviews, it's really easy and common to see conversations like, in my humble opinion, or I really believe, and you get to a point that you just keep conversation and you can think about the size of this thread. So if you take this and you really think about scope, removing noise and removing disruption actually led you to a place where you have less bias. So in practice, this is one example. This is not sensitive content, so I put in what are the architectures we have at Skyscanner, but you should definitely take it with a pinch of salt, because we're taking company context here. So you should understand what is yours. Favor single ownership and shared ownership whenever possible. Ownership is a really important matter for Skyscanner, especially when you talk about technical side. So this is one way that we can enforce this. Favor testability aligned with our testing pyramid. We don't want tests for the sake of testing. We don't want solutions that need to go to the top of the pyramid to test, because the top you go, the cost it gets. So you want to make sure that they follow from the base to the top, and you can get solutions that will follow that. Favor single source of truth for data propagation. We're not talking about the presentation layer. We're talking about the entire architecture. We want to talk about immutable data and single source of truth to avoid side effects. Favor composition of inheritance. I don't have to talk about this, right? Flexibility should not harm our ability to remain consistent. Here you can see how we brought the consistency from the product perspective and exact perspective to the technical perspective. One example, imagine that you have an architecture, then you say, okay, I really need this to be super generic so it can give as much flexibility as possible for every vertical in the product. But I say, we don't really need or want this flexibility, so actually it might be better to go for a path that is less complex and actually more consistent. So this is a way that we can avoid this kind of conversations. Layers do not cross the responsibility boundaries. You're only able to talk layers if you have the terminology or the glossary. Modeling of structs, objects, and methods should prevent invalid states. That's an interesting one, and I'll give an example later. Domain models instantiation must reflect business requirement, meaning you cannot create domain models that are bigger than it should or smaller than it should. We favor abstraction whenever possible. We don't want to get in a point where people are abstracting compose or abstracting Swift UI for the sake of abstraction. We want to do abstraction for what really matters. So about a third-party library that you don't have control, or the domain layer or data layer. Build it as if it will be consumed, but only exposed when it actually needs to be reused. This way, we want our engineers to think about creating clear APIs, but not over-engineering for things that don't need to be generic just yet. And the domain layer is independent of the other layers. This is important because we really believe the business requirement in the domain layer should be the core, no matter the architecture you're going with. So a practical example. We have this, how do we use the app policies into practice? Do I have time? I think so. So here, we're talking about the view state has a log name, is loading that is nullable, and results. It looks like simple enough to be okay. But when you go through the architecture policies, you will see that this log name, like a view should not really do logging. So I could argue that this is like layers should not cross responsibilities. The list, it has an item that is actually a domain. So rather than having a domain here, we should have a UI state. So we could say that we favor abstractions whenever possible. And here the Boolean is nullable, and that's the good example. So if you think about being nullable means it might be there or not, meaning when you have results, you don't have loading. When you have loading, you don't have results. But if you treat it like this, your API is weak, and it doesn't mean that. So you're harming the idea of modeling of structs, objects, and methods should prevent invalid states. Because reaching an invalid state here is really easy. So that, based on that, we could say this idea would be discarded. Now imagine another, like a design review, your coworker comes really excited about this idea. And they have feature A and B domain in view, and feature B, and feature domains of both feature A and B goes to the gateway directly. And the gateway comes back to both views on both features. Okay, that's amazing because we have favor single source of truth for data propagation, and flexibility should not harm, because if you keep it all in the gateway, we keep consistent. But then, or you might know this is wrong and might not know why this is wrong, or you don't just want to get in a personal conversation with a coworker, you can go to the architectures, to their policies as well. So on the policies, you'll see that layers should not cross the responsibility boundaries. So gateway should not talk to the view. Favor abstraction, we don't have any abstraction between the layers. Favor single ownership, you would have to share the gateway to be able to reach to this code. Any functionality meant to be consumed should be an abstraction. We're actually using the real implementation. So this will all be archived. And here, that one we come back later, we say, I don't know why it's wrong, trust your instincts. If you don't know why it's wrong, you see the model in between, you could go against the architecture policies again. So in this case, layers should not cross the responsibility boundaries. We favor abstraction as feasible. and the domain layer is independent of the other layers. So this one would also be archived. So we believe doing this, you reduce the scope of conversations, removing the noise, and being able to have clear conversations on what matters. So now the key learnings. Educate yourself on any architecture downsides. I'm not saying every architecture in the world, but at least the ones you're working on and you at least talk about. Really talk in depth. It will help you on your work daily basis and also help you on system design interviews if you're doing later on. The more principles and patterns you learn, the better. So this is like a toolkit. As much as you know, the more you can nitpick and choose your own architecture. We don't have to reinvent the wheel, but we can combine them together to a stronger and more robust architecture. Define your team's terminology. You don't want to be talking what presentation logic means every week. So it's good if you really have this understanding of what each layer means. Define what's your policies based on the right assumptions. If you have single assumptions and you have these guardrails, you will definitely improve the amount of confirmation bias your team has. And always enforce trade-off analysis over technical bias. This is easy to say, but I think if you follow the previous ones I mentioned, you will achieve that easier. Thank you.